We're going to be using the mean value theorem here, and so the first thing that we want to do is find the average slope for a couple of different intervals. And to do that, of course, where it's just a divided difference, we'll do f. So here we'll do slope average. We'll call it that maybe, I don't know. So f of -2 minus f of -4 over -2 minus -4. How's that? Okay, so we're going to have to plug these values in up here. So f of -2, let's see, this will be 5 times negative, this will be -15, over -2, that's going to be 1. And then f of -4 will be 5 times -5, which is -25, over -1. And then, of course, -2 minus -4 is the same as -2 plus 4, or 2. I see that I've left myself almost no room. Let's slide over, be a little bit more efficient with our space. And then the rest of this is just a little bit of arithmetic. I'll try to get it right this time. And this appears to be -40 over 2, which is -20. Let's do the same thing for this interval. So this will be f of 2 minus f of -2 over 2 minus -2. We've already done f of -2. Let's do f of 2. Let's see, 5 times 2 minus 1 is just 5 over 5. And we've already done this one, -15. And this will be over 4. So this will be, it looks like 16 over 4, which is 4. Okay, next, why would the function fail to satisfy the requirements of the mean value theorem in this interval? Well, f of, which one is it? Here, 3. F of -3 is undefined, so f of x is not continuous. On -4, -2. In this case, we're going to check that that f of x does satisfy these requirements. So let's go ahead and do this. Is it continuous? Continuous? Question mark. And the answer is yes. Oh. Okay. And that's yes, because the only discontinuity for that function is at x equals -3. And then we want to know, is this differentiable on the open interval? And the answer there is yes as well, but let's actually check. Here, I'll do this, question mark, question mark. So that one is a yes. So let's see, is it differentiable? So we need to know the derivative. So to figure that out, I'll do f prime of x. Okay. It's going to be x plus 3 times 5 minus low d high minus high d low. 5 times x minus 1 over x plus 3 squared. And sure enough, this thing is, it's got a continuous derivative. There's no problems between -2 and 2. The only problem would be at x equals -3. So that's also a yes. You can check. Okay, so the mean value theorem guarantees at least one c on this open interval where the derivative is equal to the slope, mean slope. So the mean slope is 4. So I want to find a value where this derivative, so I want to find f prime of c equals 4. So I'm going to use that derivative up there. I'm just going to clean it up just a bit. Okay, no, I won't. And I'll clean it up on my next step. So we have to do a little bit of algebra here. So I guess I'll just bite the bullet and do it. So I'm squaring this binomial. So let's see, those cancel each other. And this ends up being 20 over here. And we can move the 20 over. So 0 is equal to 4c squared plus 24c plus 16. I'm going to have to slide this over a bit and make room. So let's go ahead and factor. So let's see. It's going to be that doesn't factor. Time to pause. All right, so I just wanted to make sure I had done everything correctly. I did. So the last bit here is kind of painful because this doesn't factor, and so we want to solve this. 6c plus 4 equals 0. So I'm going to have to use the quadratic formula. So negative 6 plus or minus the square root. Hopefully you know this formula. B squared minus 4 times a times c over 2a. And so this thing ends up being negative 6 plus or minus the square root of 20 over 2. Sadly, the square root of 20 is not a perfect square, so this is going to equal negative 6 plus or minus 2 radical 5. 2 because 20 is 4 times 5, and the square root of 4 is 2. So there's those are the values for C, but are both of these or one of them in between my range here, this negative 2 to 2? I'm pretty sure that if you take negative 3 and subtract off radical 5, that will be outside of the interval that I'm interested in, and so the only answer will be C is equal to 3, negative 3 plus radical 5. I'm going to box that up. You can double check that that's in my interval, but the radical 5 is a little bit over 2, and so negative 3 plus radical 5 will be somewhere between negative 1 and 0. So that's going to be my answer there. All right, let's take a look at this one, number 2. This one's a pretty straightforward problem, similar to what we did in class. So we have these two police officers parked 30 miles apart. And so basically this person has traveled 30 miles in 25 minutes. And so we just have to convert this to miles per hour so that it matches the, so this is the average speed. And so 30 miles in 25 minutes makes, so we're going to multiply this by 60 minutes in 1 hour. And you end up with whatever this is. I'll have to do it on my calculator. So we have, let's see, 30 times 60 divided by 25, 72. And since driving is, so position is continuous, speed is continuous. So there must be some point in time. There is a point where this person is driving at 72 miles per hour. Somewhere in between those two stops. So this next problem seems to be confusing or impossible for most students, but it's really pretty straightforward. The first part, so you have two things that you want to do. Number one, establish that there is a root for this function, and then the second thing is to somehow establish that it is a unique root. So we'll do these in order. First of all, there is a root, and to do that, we need to just note that this is a continuous function, so we'll call this f of x is 3x cubed plus 2x plus 1 is continuous everywhere. It's also differentiable, which will make, I might as well, and here, I'll just put this down here, and differentiable. Okay, so maybe I should just move these around. There is continuous and differentiable everywhere. Come on. Yeah, I know you wanted to probably see a video of me doing this properly and not just moving all my words around. There. How's that? So this function is continuous and differentiable everywhere because it's a polynomial. Okay, so that's number one. Secondly, f of 0. Did I write? Yeah, I did write this wrong. It should be -1. So f of 0 is -1. You can plug it in. F of 1, there's other values that would work for this, but f of 1 is easy. F of 1 is equal to 4. You can plug this into the function and double check that this is the case. And so because of this, by the intermediate value theorem, sorry, someone came to my door. By the intermediate value theorem, there must be a point for every function value between -1 and 4, but in particular, there must be a value of c, which is between 0 and 1, where f of c is equal to 0. Okay, so there is at least one root. Now let's deal with the uniqueness of this thing. So so let's just suppose. So suppose there are 2 roots or more. Well, let's name them. We'll say it's C1 and C2. And we'll just say that C1 is less than C2. So we'll do this. Then we could apply the mean value theorem to this, specifically Rolle's theorem, because these 2 roots have the same function value. And you could say that by the mean value theorem, there must be a point. We already used C so many times, so we'll use B. Where f prime of B is equal to the average slope between those two. So I could actually just write this out. F of C2 minus f of C1 over C2 minus C1. That's what the mean value theorem says. Okay, well, let's think about what that means. That means that f prime of b would equal 0. Okay, well, let's compute f prime of x. F prime of x is 9x squared plus 2. And 9x squared plus 2 is always positive. There are no values, so if you try to set this equal to 0, then let's see, you would have 9 times b squared plus 2 would equal 0, which means 9b squared is negative 2, and there are no real numbers that have b squared equal to negative 2/9. So then there are no real numbers that satisfy b squared is negative 2/9. So there cannot be more than one root. Well, real root, I guess, technically. To f of x. All right, hopefully that makes sense. All right, let's do this one. So what values could f of 5 be for this? Well, let's use the mean value theorem. We know f of 1 is 15. And so if we do the average slope between 1 and 5 is f of 5 minus f of 1 over 5 minus 1. That average slope will match some point in between by the mean value theorem. Does this actually say? It doesn't say that this satisfies. Wow, okay, so I should clarify, maybe when I send this out, that this function is continuous differentiable. But anyway, so this thing has to be between 1 and negative 2. The average slope has to be between 1 and negative 2 because all the slopes are between negative 2 and 1. And so now we can just solve this inequality. I have negative 2 is less than or equal to f of 5 minus 15 over 4. Multiply everything by 4. And then add 15 to everything. And that gives me 7 is less than or equal to f of 5, which is less than 16. So that tells you what that should be. So I will add a little note about f of x is continuous and differentiable.